Hello, everyone. Sorry for the delay. We are very happy today to welcome you to our webinar series for the current and emerging threats to crops. My name is Dimnoma Sergio Drago. I'm the Assistant Director of the Innovation Lab and also a Research Assistant Professor at Penn State working on global food security. And today we're going to talk about AI for emerging threats to crops in extension and outreach. As you know, the impact of climate change are being felt more than ever, especially in developing countries where agriculture is driving the economies. And these changes are posing significant threats and increasing threats and disease in the crops and for agriculture. And to address this, we really need some revolutionary tools as artificial intelligence. And in that context, we would like to share with you our experience on using artificial intelligence and also leveraging ICT tools to help farmers and to be more close to them to solve the speed with that we observe for emerging disease and crop threats. So in our today's panel, we have David Hughes, that is a professor in entomology and biology, and also Hack Chair in Global Food Security. He's also the director of USAID Innovation Lab for Current and Emerging Threats to Crops. And we also have Treselin Jao, who's a research lead in Plant Village, Kenya, and also working for outreach to the farmers for the extension tools we have in Plant Village. So I'm going to give now the place to David to present us for 20 minutes before hearing from Treselin. Thank you.
Great. Thank you so much indeed, Serge. So hi, folks. It's nice to spend time with you again. What I wanted to do today was to give a presentation, which I actually gave last week. So I was at the Innovation Lab meeting. So every year we have what's called a regional meeting for the directors of the Innovation Lab. So myself and Dr. Papana Timilsena from the Current and Emerging Threats to Crops Innovation Lab, we traveled to Nepal with many others who are directors or members of innovation labs, as well as from leadership at USAID and a really broad array of partners from Nepal, Bangladesh, Cambodia, Pakistan, and elsewhere. And it was really an excellent meeting. It was really fantastic. And I gave a presentation there on the opportunities of AI. Now, we already heard about AI from Pete McCloskey and Milsort and Kembo, and also Irene Mariti. They gave a really nice presentation on AI. And I wanted to give a presentation to the directors meeting to talk about the really important opportunities we have with this. And it went well. It went very nice. People liked it. And I thought it'd be good to record this so we would have it on the web so people could learn more about it and then follow up and have questions, because that's, of course, really what we want to do. We want to be leveraging the importance of AI and the possibilities, but also co-developing it among those of us in the public sector, like the US land grants, who have this strong adherence to transparency, people who believe in leveraging scientific tools and making sure the assumptions and caveats of those tools are understood. So I gave this on April 24th, and now I'm giving it today. And it's coming from the perspective of the Current and Emerging Threats to Crops Innovation Lab. So as our lab is focused on threats, things which are problematic, we've adopted this model of SOS, the International Distress System. And for us, SOS means surveillance, outreach, and solutions. And it's really centered on youth, like Treselin, who we'll hear about later on. In this case, it's Mercy Suma, but also centered on farmers like Rosalind Akoche here in the center. And then it's encircled by the ever-present and ever-threatening increase in global temperatures due to climate change. And so because of many threats happening, biotic and abiotic, we really have to think about surveillance constantly. And that surveillance must be in a climate change world. And then as ourselves, as an innovation lab and many other innovation labs, we really need research, and that research has to result in solutions that can reach hundreds of millions of people. And so what I want to emphasize is that our innovation lab is built upon Plant Village, and Plant Village develops artificial intelligence systems to help smallholder farmers not only cope with climate change, but actually have prosperous and profitable farms. And so what I wanted to do was to show some of the AI which we have developed here at Plant Village. So one of them is pattern recognition, artificial intelligence. And you can think of that in the ways in which a website might understand what you're searching for and then give you an answer, or you may search for one thing on a shopping website like Amazon, and then you have another recommendation made to you. So these are pattern recognition AIs, and they're very common around the web. The other one is the one we heard about a few weeks ago, which is computer vision. And you can think of facial recognition on Facebook or Instagram. And then the third one is generative AI. So think of ChatGPT, which is really revolutionizing so much of modern society. So I'll go into pattern recognition first. So this is some work that we did with Amulya Yadav and his student Marion Tabar here at Penn State. And we took advantage of the access we had to the data on locust swarm. So this was coming in to UNFAO from the app that we at Plant Village made for UNFAO called eLocust 3M. And what it's doing is leveraging the data sets to run it through what are called convolutional neural networks to understand what's happening over time in terms of the predictability of the locus. So you can see a map here of Kenya where you have positive or negative data. And then from this, we're able to predict what is likely going to happen in the next couple of weeks. And this was a useful tool to be able to leverage for forecasting. And it's beneficial for many, many different pests and problems. Now, normally such predictions are done by statistical models or mathematical models. And so it's really nice to be able to see machine learning or AI be able to take over this role. Another one is also a colleague here, Xiaopeng Shen at the university and Jiangtao Lu. So in this case, they're leveraging access to data from the NASA satellite called SMAP, which is measuring surface moisture in the soil. And so in this case, we have data from across the continental USA, and they leverage all of this excellent data from ground stations to act as a ground truth for the data from the satellites. And then they improved it through what's called a long short-term memory model, actually a Fourier transformed long short-term memory model. And they were able to really exceed the predictability based upon their approach. So they got a really, really high accuracy compared to previous approaches, which were oftentimes mathematical or statistical. And also they were able to leverage the data from the United States and apply that to areas in Africa or North Africa and South Africa. So this was great because Africa does not have the broad array of ground stations. So using machine learning was effective there. And the final one is also with Amulya's group and Mariam. And so in this case, we took biomass data, which was measured by two NASA satellites, MODIS and Landsat, and also using what's called a Penman-Monteith equation, and then looking at the growth of things over time. And these three examples show us that if you have a sequence of data, it doesn't really matter what it is, insects, soil moisture, or the growth of crops, if it's a repeatable signal, then you can predict what's likely to happen in the near and midterm future. So that's a really useful application of artificial intelligence that's going to get better and better. Now, in Plant Village, we have lots and lots of data for this, and it's all free, it's all accessible, it comes into our system, and every time people are using our app in the field, we're collecting this type of data on those locations in order to enable better predictions for how crops are going to do in a different agroecological zone or in a different circumstance, or maybe with a different treatment, such as the application of biochar fertilizer to the soil. So the second part is computer vision. This is really the primary way in which Plant Village has been pioneering the use of artificial intelligence over the last number of years. And so a big component of this is trying to get computer vision AI into the hands of people who might need it. And a large part of that is building apps. So we built the Fall Army Worm Early Warning System app for FAO. We built SUSE Hammer for FAO. We built eLocus Tree M for FAO. We previously built one called Farmer Zone for India, the Plant Village app itself. And then this one we've built with and for IFPRI for adolescent girl diet. So this is also another one that we built. So it's really important to be able to build the apps to deliver the computer vision AI. So here's a sort of a classic picture that we often show where we have a smallholder farmer, Rosalind again, the one you saw earlier, and she's with her neighbor Emiliana. And what Rosalind is doing is showing Emiliana the problems that she has on her cassava plant, and she's leveraging an AI system that's inside the phone that works offline. And so we developed this based upon knowledge that we were able to access from the International Institute for Agricultural Research, or for Tropical Agriculture, IITA, and we were able to then repetitively train the model and then put that model inside the phone. So Rosalind doesn't need access to the internet to access this, which is really important. So we've got two types of computer vision. We have the one that you just saw Rosalind demonstrating, which is called object detection. And then it uses a very popular system called TensorFlow, and it's a convolutional neural network inside the phone. And then we have something else, which is more complex, which works in the cloud, and it's called segmentation. So in this case, the computer is looking at every pixel on the plant, you can see here, and then it's able to discriminate what is the background, what is the plant, and then also pick up instances of disease on this. So this has to go into the cloud. It's a very cool system where you chop the image up into multiple parts and you examine it, all those individual parts together. And here's one for late blight on potatoes, the Irish potato, as it's called in Africa. And here's one at healthy. And these are really great because we get the ability to diagnose diseases offline in the field. But with the Potato Institute, what we're doing there is then having a decision support system. So this is funding we give from CETC to SIP, the International Potato Institute, and they're able to help farmers make decisions on whether they should or should not spray fungicides. And this is really great because it's effectively helping farmers reduce by about 30% the amount of spraying that happens, and that saves them money, and it also reduces the evolution of resistance. Here's another one on coffee. And so we have this for two fungal diseases. We have one for coffee rust and another one for red blister disease, which is also a real problem in coffee systems. So that's very effective in helping people identify the problem and then, of course, make decisions on the solution. And so in Plant Village, we've really understood lots of different things and helped bring AI to Africa at scale. Here's a graph of the records that we see. So really high penetration of the use of the app across the continent. And that's very helpful when we have emerging threats, like in this case, banana bunchy top virus, which is an emerging threat in Tanzania. And so we're able to help the Tanzanian authorities deal with this problem and then also diagnose it. So here we have banana bunchy top virus. Because Plant Village works in many countries, we've been able to develop this rapidly in Tanzania, Uganda, Malawi, and Kenya, and also get lots of testing done. That's really has been really an excellent way to demonstrate the importance of having lots of people out there in the field collecting data. So I can switch over to the site and tell me now, Serge, if you don't see the site, but here we have the data coming in. So we have it kind of gridded. This is data for Tanzania. And so you can go into the squares, which are 10 square kilometer radius. And so in this case, the people in the government could look at this and try to understand what the AI said and whether it was correct or not. So in this case, it's picking up a diagnosis of nutrient deficiency. You
We
can
are
see.
not seeing the square, sorry.
Oh, okay. They're not. Thank you. You're still seeing the square. Okay, thanks. So I just clicked on from here, and I went on to this page. So this was the map that we had, and then it went over to here. And so this allows us to update what the AI said, examine what the AI said, zoom into the location, and then try to figure out, was it correct, and then improve it. So we get this ability to collaborate with the AI in real time, which is very cool. So I'm just going to go back to my presentation. So that's the map of the AI recorded observations. And now we want to compare that also to coordinated pathogen surveillance. This is some work that we're sponsoring at the University of Florida, where we have these small nanopore sequencers. We previously sponsored these work in Nepal and Ethiopia through funding to CIMMYT and John Innes Center. But now we want to expand it to lots of new problems. And this is a really interesting approach that is very good at detecting a wide array of pathogens. And so the nice thing about the system is that the cloud system allows AI experts to check the AI. So in this case, we could see an observation by Felicien in Mozambique. Then people can come in and look at that and see if it's correct. Here we have an expert from that institute I mentioned earlier, IITA, and this person is an expert on banana diseases and now is able to look at the surveys and correct them. And that's really important for the engineers because they can update the models and retrain based upon human experts. And this chap here, Andrew, he may have maybe 10 or 20 or 30 years experience looking at banana diseases. So we get to build our AI based upon this deep understanding. Now, with all of these observations, we want to help the government make decisions. So this is what the Plant Village Tanzania team did. They went into a government office and they worked with the people at the Tanzanian Plant Health and Pesticide Authority, and they did up the room that wasn't being utilized, and they made this observatory, a Plant Village AI observatory. And this is really excellent because now government officials and others can see the data in real time as it comes in. And so we see this, here we have Benuid presenting to Joseph Nguru, Professor Nguru, who is the head of the Tanzanian Plant Health and Pesticide Authority, as well as the board, the whole board of this. This is really great. It shows the government officials the promise of AI and the potential, and they get to work with people like Benuid and also Verdiana in understanding this, because young people are really excellent at explaining technology and to older people, and they act as a bridge. And here we have Tor Edwards, who is the USAID mission in Tanzania representative and a really great advocate for this sort of approach. So surveillance and then outreach and solutions. These are also important components here, the outreach and solutions. Just very quickly, once we start to have these maps, we're able to understand where we should be educating people through outreach. And one of the things that we've developed at Plant Village or at the Plant Village road shows for, in this case, for banana bunchtop virus, but it can work for anything. You turn up with a bus, you get out there, you start helping people understand the problem and distributing information. And then this allows us to better understand research and explaining knowledge. So in this case, we have again Thor. I like this picture because we have a person here, James from Kenya, but he oversees Tanzania. We have Salome Kugale from Uganda, John Chalal from Kenya, and Joachim from Tanzania. So I really like this. Multiple countries. And then we have these tissue cultures here and trials of how the research is going. So the maps, the education, and then also the research. In some cases, we have a system whereby we can add little microscopes to the phone so we can better understand the types of diseases which are very hard to understand with the regular phone camera. And then we also are able to leverage this for food recognition. So this is the work I mentioned with IFPRI and the University of Ghana, where we're able to diagnose food and then do that effectively. So understanding the relative carbohydrates or protein or even micronutrients in the food. And this is for a school meal system in Ghana. And this is really cool because we can see over time as people are using it, we can improve their diets. So we can do this detection, which is 200 times cheaper than humans. But now the phone and the AI is able to track a person over time, in this case for 30 days. We've just recently finished one which lasted 60 days. And so if you're being followed over time with this AI, it leads to better diets, better outcomes, healthier eating. And this difference here in the Lancet diet score of 1.1 is a really, really big difference. So you can see how people would be moved towards healthier diets. And it's not just people in the global south, globally. Increasing weight and obesity is a challenge for a variety of reasons, for the individual health and also for society. And so having a phone help you eat better over time is a pretty major breakthrough if that phone leverages AI, but only if the AI is transparent. Here's another thing that we're doing. We have multiple companies now who are using our AI to help them capture and store carbon through the app that we built for biochar, which is the conversion of waste biomass into biochar or carbon in the form using pyrolysis. So there's a lot of people. Over $500,000 to farmers. Actually, I was hearing from Carboneers, one of our companies, that I think they've distributed over $1 million into India just alone. Really impressive. Huge amounts of money could be coming into the smallholder farmers, leveraged and helped by artificial intelligence. This is another one that we've been doing on measuring trees, helping the growth rates, because it's not about planting trees, it's about growing trees. And the effective way is to use something of known size. And this is from Edward Amoa's PhD thesis at Penn State, which is an effective way to look at how we can measure tree growth over time. And the Plant Village Kenya team has been very helpful in gathering data for this. We don't use AI on animals, but we do a lot of animal surveys. And so that opens the possibility of using AI for animals. Okay, so this brings us on to the last one, which is generative AI. So you can think of ChatGPT. So at the moment, we have a system in the cloud where we enable, and Tracy will talk about this, where we enable people to send messages. So in this case, we have a message from Plant Village Nepal, which is a private sector organization in Nepal working with government and other partners. And Prabha here has sent a message to a farmer who has been experiencing some problem of fungus on other vegetables. And this is great because Prabha has a master's degree in agricultural sciences and she's knowledgeable, but it's limited. So in which way could we help people like Prabha be able to scale up the answers, but make sure those answers are being checked and they're importantly as correct as we can have them. And so here's a short video showing the process. So in this case, if the record has been labeled as having a type of problem, so in this case, the problem is on beans and a fungus. So let me just pause it so you can see that. So just go back a little bit. So in this case, you have beans in Malawi with a fungus and an insect. So, and then if you make those designations, if you click on that, then the AI button is available to you, and then the AI gives you an answer. In this case, it's a variant of ChatGPT running on our corpus, on our bunch of data that we have. And then here's another example. So this case, you can have a human override it or add some details. And I think that's really important. We want to look at AI not as a replacement for humans, but as a co-pilot. And then somebody like Prabha could say, contact the local office. These are the kind of decisions that humans are good at making or adding in addition. So a lot of features using AI in settings like the medical field or in law are going to look at AI as a co-pilot rather than as a replacement. And over time, we may see it replacing, but we certainly want to look at it as a co-pilot. So this has led to a new experiment we're doing as part of the Innovation Lab. We want to look at a commercial model of, this is Justine, one of our farmers, a commercial model of AI-empowered agents. So Justine is incredibly well respected in her community, and people really, really like her. And so this means that she's able to disperse these biological control agents for fall armyworm or biochar fertilizer or better seeds. She can sell these things to farmers, and now it's her job to sell. But she's also empowered by the AI. And so we're thinking of ways in which we can leverage Justine, the trust she has, and the AI to do surveillance under reinforcement financial engineering and rewards, otherwise known as SURFR. So the idea would be that if she's being paid for this job, and can we collect data as a side effect of her main job, which is to help farmers buy inputs, and can we have this as a financially engineered mechanism, meaning if she doesn't be collecting this data and that data is not useful, then she's not employed in this role. So we want to make sure people are employed in this role, and we can result in having surveillance without paying extra for the surveillance, because she's helping to sell these biological control agents. And then there's reward. So if she's particularly good, in which way can we structure it to give a reward to Justine and others? So here's some outputs. So you can see Justine here. This is prepared by Brian on the team, a really excellent data scientist, able to now oversee all of the sales that we've had and what's happening. And we can start to look at this. And this allows for that reinforced engineering. So in this case, these are agents who are no longer in plant village because they were not selling or doing the work. So we really want to make sure we're rewarding people, but also understanding if we're getting the work done, because under climate change, we really need to get the work done. We need to do surveillance at scale. And you can see here, it's recognized here that she's a Plant Village Plus agent, and she's collecting the data. And then, as we mentioned, from all of the satellite data, we can really interrogate that field to understand how well it's doing. And then this is our dashboards that we're able to use in Superset in order to determine how well it's doing and how often we're getting these records in. So we could get to a system whereby we have huge amounts of data coming in over time, and then we can understand how well we're dealing with the problem, or how much of a challenge that problem is, how much we have to mobilize resources. And this is going to lead to massive cost savings over time for the international community. So we don't have to run around all the time in panic. One of the things we mentioned in our application for the Innovation Lab was to move away from this pest of the week mentality. We need to move towards prophylactic systems, which remove that reactionary status we've been in for a long time. So it's really critical to have young people acting as bridges, as we mentioned, especially because we're helping farmers in an analog world use advanced AI. And this rests upon the youth system that we've had, the Plant Village team members, which are now in, actually this map needs to be updated. They're in multiple countries and doing very effectively. So that's an overview of our system, and I'll stop there and hand back to Serge and also to Tracy. Thank you so much.
Yes, thank you very much, David. So just to remind people, if you have any questions, just feel free to write in the Q&A section and we cover them later. Thank you. So Tracy, to you.
Thank you, Serge. I will talk about what we just do as a team, and also what I will present in is some of the data that we are able to get from the surveillance team that is on the ground. So I'll just share my screen. Yes, so this is the overview of my presentation. I will present about the surveillance team, then the top threats per country, then the surveillance data, and what we basically do. So, so we have teams in these countries. Basically, for the surveillance team, We have teams on the ground, the field officers, the plant village police field officers who are in the fields collecting data using the Plant Village app. And they collect data from these countries, Kenya, Uganda, Tanzania, Nepal, Mozambique, Ethiopia, Malawi, Burkina Faso, and other countries that have just been introduced, like Zambia. Yeah. So most of the surveys that we do, most of the work that the app does is science, pests and disease surveillance, and other also that David has mentioned before, like for biochar, and others are used for research. So we can be able to see that from this data, the most use of the app is on survey and research. Yeah. And surveys are these, we collect data on the plant diseases in various regions within these countries. And it comes to our end, and we have the back end team that responds to the farmers or the questions asked by the team collecting these surveys from the field. Yeah. So these are just some of the activities that goes on. Most of the time, our field officers, they train the farmers to use the Plant Village app on their crops, such as this one is a farmer taking survey in the field using the Plant Village app. Here is a research officer in Zambia, also being trained by our Plant Village officers just recently on how to use the Plant Village app in diagnosis of fall armyworm, yeah, in Zambia. And here in this other photo, it shows the solution that David has talked about. So after finding the problem, we end up supplying the solution to the farmers, such as for the control of the BPTV, where we supply the clean tissue culture bananas to the farmers. Yeah. So we get a lot of data from our end. So we are able to see that most farmers have been using this app to diagnose plant diseases. And we are able to see that lots of the plant village officers based in these countries, they are able to send in information, and the farmers are able to get information on their back end. They are able to use this app in a way that the plant villagers officer, for example, here in Malawi, where we can be able to see that the farmers have the farmers are continually increasing using the app as compared to the plant village officer. So this is our aim as a company, that at the end of the use of the app, we are able to use this app. Many farmers are able to use this app to diagnose their plant diseases, and we are able to give them the management options. Yeah. So also what we get from our work, maybe before that, I will just present what we do by logging in the website. We have a team on the back end system, the surveillance team that now are acting like online extension officers that respond to the farmers. And what they do is that they respond to the questions that farmers are asking once they have done surveys using their phones in the field. So for example, a case like of today in Malawi, a farmer will take in a survey in the field, and then we will be able to click on the survey, for example, this one. And then as you can see, there is our field officers, Leonard Tawakali, has been able to indicate the threat to this particular disease. So our team, what it does, it will look at the threats. We will click a picture by a picture. So for example, this one, we will click on the photos to clearly visualize the symptoms of the plant disease. And then we can be able to see, like, for example, this leaf, it clearly shows that it has been affected by insect or leaf defoliators. So after that, we will indicate that threat. as shown above, we have indicated that the leaf has been damaged by insects. And then after that, we are able to send a message and say, hello. For example, this farmer is called Noel. So we will be able to say, hi, Austin took the survey in Noel's field. So we will be able to tell Austin that Noel's farm has been affected by insects, and we are able to give the diagnosis of the plant disease. So for example, we say here, the leaves have been affected by insects. And then we can advise the farmer to monitor early mornings or to monitor in the evenings to see the pests, the pests, so that he or she can take another survey to our team, and the team can be able to diagnose on the proper control method based on the insect that will be there. Yeah, so you can say here, you just tell that information to our field officer, and the field officer is able to now advise the farmer. Yeah. So also here, maybe what I can mention is that we are also integrating AI, and here we will be able now to integrate this with the ChatGPT and also upcoming Gemini. We're able now to link Google with our feedback so that it is more accurate, so that even if we assign a threat to a particular plant, we are able to give the solution based on the current information that is on Google and that is available with our other AI. Yeah. So that is it. So I can now proceed to sharing my slides. Yes, so from the data we are able to see, sorry. Yeah. So from the data, we are able to see that you can find threats. You can find that fungus is a major problem, for example, in Nepal, and fall armyworm is a major threat in maize. And then in Kenya, fall armyworm is also a major threat. And then Uganda, fungal is a major threat in bananas. And that's why the picture shows that Solomon, who is the lead for Uganda, is able to integrate with Tanzania, who are providing solutions to the farmers on bananas. So we are integrating systems to reach out to the farmers, and so that we can see on a way we can bring these solutions together for the benefit of all the countries we are in. Yes, so we are able to track all the countries that our field officers are based and get the most important threats. So apart from that, yeah, so we are engaging also our field officers to provide these solutions to farmers, And then the farmers, they teach the farmers on how to take care of these crops or take care of these solutions through the brochures, through field days, and through also farmer meetings, and also research officers based in their regions. Yeah. Thank you.
Thank you very much. So we have few questions that are already being posted. So I will take for Jonathan that have a question for David. So how do you see Plant Village Plus model, which is now obviously developed from a pre-competitive space, now competing with the commercial sector?
Yeah, thanks, Jonathan. Obviously, we don't see it as outright competition, which is unfair. So in all, I would say in the majority, if not all, of private sector offerings, there is a huge benefit from public sector investment. M-Pesa, for example, was invested into by DFID, the UK aid agency, to a grant, I think the Vodafone initially, and pharmaceuticals benefit from investment from the public sector, and so on and so forth. Tesla had an enormous loan from the government. So these are investments which then enable private sector offerings. It's part of the university structure that we should be seeking to commercialize some of our approaches. But we don't see this as an exclusive benefit to Plant Village Plus. The AI is for everybody. Anybody can use it. So your company can use it, others can use it. We hope that they do. We hope that people go on to fields using this AI to improve your competitive offering. So in your case, if you're selling fertilizers or seeds, your agents could use this. And then the distinguishing characteristic is that you maybe have a better relationship with the farmers, or you have some local blend of fertilizer that reaches them in a better way. So we don't see it as a negative, that we have an unfair advantage or anything. We see it as a way to leverage public investment to help the private sector, ourselves and others, in order to do what we all want to do, which is solve poverty and climate change. I hope that helps. Thanks.
Thank you. So, analyst, can you help me to ask if Jonathan, do you have any other a follow-up to David answer, or it's good?
Sure, give me 1 minute.
Mhm.
Okay.
Hi there, David. Thanks so much. Yeah, I think that explains it well, and I think that's a big concern for us now as big corporate, right? I don't think you guys have such a massive amount of traction that it would be ridiculous for us to not figure out where we partner, especially in emerging markets. I suppose again, these initiatives on your end, on the incubation side, and our initiatives on the delivery side for certain things must marry somewhere and must meet somewhere in a space which still offers enough content at the public domain space as well, not entirely the private space. And again, I see the tools you've proposed, especially in the markets like West Africa and East Africa, where we are specifically trying to bring in organics as large fertilizer organizations. We're trying to bring in organics and marry that with a suite of solutions for farmers. So I do see this going in that direction. I just think we haven't really had a chance to map that out. So I think maybe we need to figure out how that works. And I suppose it's not only us. It's our competitors like Yara and ETG and OCP. How do we leverage these solutions for a private public sector? I think that's the question. So yeah, I really think you guys are doing phenomenal work. Keep it up. Well done, man.
Yeah, I think you raised a really important point that was also raised by Mark Husenga at USAID. We'll send him this recording if he's not on it, but also Jerry Glover, also at USAID. So there are places where the market is failing. So for example, in Nepal, where we were, there's a lot of people in the hill regions which don't have access to seeds for wheat. And so they're growing legacy seeds from the Green Revolution, and that's leaving them open to diseases. And that's because the marketplace doesn't want to send up seeds into the high mountains because it's expensive. And so they sell them on the flat areas. So maybe the approach could help in those areas where the private sector is not operating. But at the same time, the bit raised by Mark at USAID was we have to be careful not to have unintended consequences. So we don't want to crowd out existing private sector players. But on the other hand, we want to kind of raise the game. So in which way can we raise the game for private sector delivery? So we work with a company called Toothpick, a private sector group that came out of Montana State. So we could be helping them through this application. So I think you raised an incredibly important point that we think about a lot. I think it's not just our decision to think about it. It's industry people like yourself, it's USAID people, it's government, so that we don't make mistakes and then 10 years later we think, oh no, that was terrible. Because when Facebook came along, everybody thought that's great. I can keep in contact with my friends and see, videos of cats. But 10 years later, we had a huge negative impact on democracy from Facebook. So we want to make sure we're doing this properly, and the more people transparently examining what we're doing, the better. But great point, Jonathan. Thanks.
Perfect. Thanks, guys.
Thank you. So, Lawrence?
I can answer if you go ahead, Lawrence. Yeah. So Lawrence was asking, is going to ask, how do we prioritize and select crops that have been affected by a certain threat to provide long-term solutions, considering that farmers and extension officers use the app for a wide range of crops? That's a really important question, Lawrence. I guess mostly in a demand-driven way. So if people are really concerned about something, so for example, banana bunching virus, that was something that people were very worried about, and it became obvious having a surveillance tool operating at scale would be a really good idea. Maybe, thinking about something like Bambara groundnut. I'm sure it has many threats, but we're not hearing a lot of requests for that. So doing it in a demand-driven way. But the other way is being able to parallel process. So by setting up these AI labs, we have one in Kenya, we're setting up one with Lunar in Malawi. We have one in Ghana, at the University of Ghana, for food. When we get to the situation of having 50 of them, then people can just be doing the models all the time. It's a little bit like Wikipedia. There used to be a time when you just had one encyclopedia production, or maybe two, but like Encyclopedia Britannica. And now you have encyclopedias everywhere in the world, so everybody can write whatever they want at any time. So that's the kind of future we want to have through Plant Village AI. So people can be making these, but importantly, a situation whereby if you make a new model and AI for fungal diseases on Bambara groundnut, somebody can check and see it's correct. That's an important point. Thanks.
Thank you. So, Lawrence, do you want to add something?
Hi. Thank you. That was well explained, David. I think it has really captured what I wanted to hear about encyclopedia and having the list of different crops and the priorities. Thank you.
Thanks, Lawrence.
Thanks. So if anyone has a comment or a question, just feel free to raise your hand and we can unmute you. Yeah, something I really want to quickly add is the potential to be close to the farmers with the tools, because we know we living in many places in Africa and most countries, we have the rate extension officers to farmers is really low. We couldn't cover all the farmers, and even we're living in the perfect situation where we have extension officer for a small number of farmers. We cannot be close to them, and this way that we have some, maybe say aphids or whiteflies popping out in the field and can just wipe out everything in less than a week. We need to really be close to the farmers and be able to assist them even we are not physically with them. And these tools are really good, because just telling a farmer to start applying ash or using soapy water or something to get to control the pests is really important. In that case, that can help a farmer to save like $100, $200, and it's a really big potential to have the opportunity to see what the farmer is really having in the field and ask them to provide more pictures if needed and assist them. So if we're really living in the situation where we would like to get in touch with more extension services in the different countries to give them access to the tool and help them to do better their day-to-day job, because that's at the end of the day is to help the farmer to grow more food. So, and I will be posting our email addresses, and just feel free to contact us if you have any question. If you have any, you want to collaborate with Plant Village team or the CETC team, just feel free to contact us and send email. We can schedule a meeting. We can have and see what are you doing in your country, what are you doing in your section, and how we can help you to make your day-to-day job easier. So that's what we're really looking for, and serve farmers better.
Yeah.
Yeah.
Sir, do we have Nozomi who raised their hand and question? Would you like to take it?
Yes, sure.
Okay, let's go to Nozomi first. I'll allow you to talk. Go ahead.
Okay, can you hear me?
Yes.
Yes. Thank you for presentation, David and Tracy. It was excellent. I'm Nozomi from CGIAR Plant Health Initiative. My question is, do you collaborate with government, national government, because your surveillance can really show evidence for the government to set the priorities for the budget and extensions?
Yes, thank you so much for joining, Nozomi, and also for the question. Indeed, we do. We collaborate very, very deeply with government, and we prioritize that. County government, for example, in Kenya with the animal tracking that we saw. National government in the case of Tanzania with the emerging threat of banana bunchy top virus. We really see our role as to improve the capacity for government. In Malawi, we're actually training government scientists in the use of AI through a NORAD project that we have, and we're in collaboration with others. So these are really, really impactful things, because government is ultimately the one that can implement changes in bylaws for quarantining or policies that prevent the movement of restricted material, like in the case of banana. But also government is the one who has citizens, and citizens pay tax. And this can increase the capacity for doing more and more surveillance. So hugely impactful to work with government and enable them to be trained, and they're trained by their own citizens. Tracy, if you'd like to add a few words on your experience.
Yes, sure. Yeah, so we are collaborating with various institutions and governments, and mostly like what we do is that once we get inside the country, the first people we are looking at is the researchers and the government people in that country, and then we link with them. First, we like, for example, in Tanzania, what we did, we first realized there is a threat of BBTV, and what we did is we collaborated with the Tanzania Plant Health Inspectorate Service, and they went ahead and said, indeed, there is this problem, and with our tools as Plant Village, we can help solve this. So what we did is we created a training ground for the researchers, the plant health researchers in Tanzania, and we were able to, they are able even now to train even the government extension officers. We trained them, and now they are working together with our plant village officers to create an extension outreach to farmers, and also to emphasize the importance of managing this particular disease in that country. Yeah. Also collaborating with researchers, we are also liaising with researchers in IITA, CIMIT, just TARI and ZARI, as you have seen, so that we can provide these solutions to farmers. We can easily reach them. Yeah.
Okay, thank you.
Okay.
Great.
There were a few questions in the chat. The one was pretty much addressed already with the government bodies. And then we also had Daniel had a question if you wanted to take that.
So Mulligan asked, what is the main challenge in extension work? It's lack of access. It's just a barrier to getting into the fields. And so we want to empower extensions. And a really great way is to leverage other people. So if you have an agent like Justine, which we talked about, or Rosalind, then they can be collecting data easily at wide scales, and that can help people. We work with a lot of the Morans in Kenya, and that their surveillance helps the vets to combat it. And so what the second question is, what is needed to start animal AI in Ethiopia? I guess we're still practicing in Kenya, but well, it's always, the answer is always willing local partners. You know, if we have somebody willing, we can go into Burkina, we can go into Ethiopia. We don't have to stay where we are. we can do multiple experiments. Thank you. Daniel?
Hello, everyone. I just wanted to put some input. I'll start with the collaborations. We're doing a lot of collaborations with the county government, the national government as well in the research level. Like, for example, the examples have been given by Tracy and David, HEFIS, we have TPHA, we have CALRO. And the main target here, as the speaker who asked the question, is to make sure that we are able also to influence policy. We believe that most of these policies need to be informed, because these are the people that decide where and how this information can be used, and even the technology. So they sit in the parliamentary committees, they sit in the most important decision-making bodies. So once we have access to them and we have a discussion and we collaborate with them, then we can be able to escalate our case and also our data, our research, and it can be incorporated into the government systems, and they will push for us. Like, for example, in CALRO, we hope that we can be able to collaborate with them and utilize the 15,000 entrepreneurs they're having to pass information, data, and extension services to the farmers on the ground. So they really play a key and crucial role when it comes to our work. And as well as when it comes to what we do, we believe that once we have these policies, incorporating the work that you're doing, then we can be able to have an easy way to access the farmers and also be able to provide the services that we intend to these farmers. About AI, and I guess this is the most interesting part for me, is that I look forward to a situation where it becomes like a syllabus, like what David has said, an encyclopedia, a syllabus whereby we actually having it taught to our farmers each and every single time by the county governments or those people in charge, the extension officers, where we do not now have to have people always going to the field, but we have it being adopted just like the school curriculum, because we have programs that are like curriculums in our county governments, in our different bodies and institutions. So we are hoping that Plant Village can be able to help push that we be in a position that AI can be seen not as a tool to replace, but a tool to assist, help, and just provide solution outreach and surveillance, as we always said. So it takes a village, and I believe that each and every step that you're taking currently is exactly towards the goal of achieving that, making sure that AI or artificial intelligence is accessible to even to the very remote farmers in probably a place in Turkana or Samburu. So these are some of the things that I enjoy, working around with. And every time you go to the farm and you find them having a conversation with our blue t-shirt or the Plant Village colors, then you'll feel proud, because they might not be able to exactly tell you what's happening, but they're able to carry out the research, the survey, and a team will be there to guide them through. So I guess it's been a journey that when you look at AI, that's that transformation. And for us, we feel like the best way to go is to have it being adopted as a syllabus, being taught. And that's why we even incorporate school kids. We incorporate the young people, because the conversation is always, when you're at home, a child will remind you that, today I saw an app called Plant Village, and they'll want to test it with their parents. And through this, we can be able to keep on having a sustainable way of passing information from one generation to another. Thank you.
Thank you, Daniel.
Yeah, thank you very much. I think we went over our time, and it's really interesting discussion. And like I said, feel free to write us an email and keep in touch with our team. We really will be happy to have schedule a specific meeting with your research group, with your country department and everything. We really there and have represented in many countries, so we can have a physical meeting if you also would like to schedule a meeting with our team. So thank you very much, and see you in next 2 weeks.